All right. Now in step 6, which is our last step, we're gonna fill out the blanks. Okay, how those four triangles help us fill out the blank. Now I want you to help you to show you the bridge between the triangles and the blanks. So let's start from the first coordinate system here. Here we want to know how much ER is on I direction, how much ER is on J direction. So that can be reflected on the triangle we built. So ER, let's look at the triangle with ER. So inside of this triangle here, and one edge represents the direction on J direction, and another edge represents the length on I direction. So in another word, and the length of this edge right here on I direction should be the magnitude for this blank, and the length of edge on J direction right here should be the magnitude for this blank. Right, if that makes sense to you. Similarly, for E theta, this triangle, this edge, the edge that's parallel to I direction, should be the magnitude for this blank. And the length of this edge, which is parallel to J direction, should be the magnitude for this blank. Alright, now your job is to find how to write expression for the length of each edge by using the given theta. Alright, it's pretty easy. So if you look at this triangle in ER, it's a hypotenuse. In this case, we treat all the hypotenuse as given, since both ER, E theta, they are unit vectors, so their length is 1. So we know the length for hypotenuse right here and right here. So if you know that this length is 1 and you want to find out what is the length of this triangle, which trigonometry would you use? Would you use sine or cosine? So in this case, since it involves this length, edge, and this hypotenuse, so you probably want to use cosine, right? So the first blank we're gonna have is cosine theta. That's it. You don't have to worry about the signs because we did that in step 3. And all right, now do the same analysis for J direction. What's the length of this triangle, right? This length. And would you use cosine or sine? So you definitely want to use sine, right? Because sine theta equals the length of this edge divided by the hypotenuse, which is 1. We know the length. Therefore, the second blank should be sine theta. Okay, now you can do the same drill for E theta. Hypotenuse, consider that's given, and when this is a theta, so if you want to find how much E theta is on I direction, that should be sine theta divided by the hypotenuse, which is 1. Sine theta. And for J components, we're going to have cosine theta. Alright, same drill for the second coordinate system. Let's look at the hypotenuse for I first. Consider that's given. It's a unit vector, so the length is 1. If we want to find how much I is on ER direction, ER is in this direction, we want to find out the length of this edge. And we can use cosine theta, going to be this length divided by the hypotenuse, which is 1. So the first blank is going to be cosine theta. Of course, the second blank is going to be sine theta. All right. Now let's move on to J. Then you want to look at this triangle with J as a hypotenuse, and we have theta right here. How much J is on ER direction? Which edge you should look at? The edge you should look at should be this edge. This is on ER direction. So that involves this edge and this length. Wait, would you use cosine or sine? Of course you want to use sine. So here we have sine theta. Of course another blank is cosine theta. Alright, now so far at the end of step 6 we figure out the signs, the values inside of each blank. Now you should have a complete conversion equation for these two coordinate systems. Thank you.